Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 2316. Count unreachable pair of nodes in an undirected graph. So it's a really interesting problem, and there are various ways, with which you can tackle this problem. So, for example, you can use DFS, BFS, or even I think Union Find, which I tried, but uh, I think that was getting a lot complicated. I got the answer, but that was getting a little complicated. So I pivoted to DFS. So what we have to do is like we will be given an array edges, which will basically represent an undirectional edge between 2 points or two nodes. Okay, and we'll get an integer value called n, which will basically represent the number of nodes we will have. And we have to basically figure out how many pairs are unreachable from each other. Okay. So for example, in example number one, all the pairs are reachable or all the points can be reached with each other, right? But in example two, if you see, you cannot reach 3 from 0, right? You cannot reach 1 from 0, or you cannot reach 6 from 0. Similarly, with all other nodes. And similarly, if you follow the same pattern, you will not be able to reach 3 from 1, and so on and so forth. So I figured out a pattern in this problem. So if you will be able to find out the connected components, right? Then it's gonna get very simple, and it's gonna get trickled down to a permutation and combinations problem, okay, in which you will basically find out the total number of pairs possible with n, okay, and you will subtract number of pairs in same component, okay. So this is what we will be doing, and let's just move towards the solution, and I'll explain you what exactly we are doing. So okay, so first things first, I want to create a adjacency graph. So, it's kind of a religious practice that whenever you do BFS or DFS, you will create a adjacency matrix for yourself. So let's name it graph, or you can name it anything else. So for I, and let's make this what we will expect a list always. So what I've done over here is I have created a dict in which default value of any key will be list so that we don't get key error while inserting any key. Okay, next is for edge in edges. I will just create a create a edge between these points. So in edge, basically you will have source and destination, right? And it is a unidirectional graph. So graph originating from source, and I want to append destination into it. And the other way around is also true, right? So you can reach to source starting from destination. So this will basically create our adjacency matrix. Next is I want to create an array called visited, which will basically store information about all the nodes which we have visited. And just to make it computationally efficient, what I'll do is I will store pause for all the nodes initially. Okay. So how does it make efficient? So, when I started my practice and in my initial years, I came to know that if you assign a variable with a definite size, it's always efficient rather than, creating it on the go or dynamically creating or appending anything into the array or any other data structure. Okay. Next is what I want is I want to create DFS now. Okay. So let's create the helper function for DFS. And in DFS, I would expect one node at a time. Okay. So what we'll do, we will check if the node which we have received is already has been seen or not. So how will you do that? If it is already marked true in visited, then you don't need to do anything and you can just simply return false from there. Okay. And one more thing, like this DFS will basically return the number of nodes in a single connected component. Okay. So just to give everyone a reference. Next is I want to mark this node true because now we are processing that node. Okay. Next is result. So initially, like why this variable has been set to one is no matter if it's a connected component or an unconnected component or in even a single individual node. So this will be the minimum value because every node in itself will be a component, right? No matter if it's a connected or an unconnected component. So that's why the initial value is one. Now, simple, you have to traverse for all the neighbors starting from this particular node in our adjacency graph. Okay, and you will just keep on appending. What is this? Neighbor. I just hope there's no typo. Okay. You'll keep on appending into your results, like number of components in a connected number of nodes in a connected components is results. And at the end, you will just simply return result. Okay. So this part is also done. Next, what you want? I want to check how many components I have received, how many connected components I have now. So we will basically initiate this DFS for all the nodes which we haven't seen after initializing. So how will you do that? For let's say node in range n. So we are basically checking for all the nodes. For example, we'll check if zero is invested or not. Okay. If not, then we'll pass it on for the DFS. If not of visited node, so this will basically ends up true. I will, this is not needed. We can simply add that into our component. So, sorry, this should be what DFS of node. So what exactly is happening over here is we are checking how many nodes are there in a single component starting from a specific node. Let's say starting from zero or starting from one. Okay. So after finishing this, like we will get all the connected components with all the relevant information. Now comes the mathematical part where I wanted to check how many total number of connected pairs are possible with n. So to do that, we have a simple formula n into n minus 1 divided by 2. This is the simple formula. Okay, and you must have seen this formula somewhere. Or if you want, like you can also interpret it as a combinatorics formula NC2, let's say. Okay, where n is your actual n, and we have taken 2 because we there will be a pair with at most 2 nodes in it, right? Okay, once this is done, what you have to do is you have to traverse your components and we will basically just subtract out all the possibilities we have already there. So, for example, there was a component with 4 nodes in it. Okay, so we will subtract out all the pairs we can have from those 4 nodes. So we'll use the same formula. We'll just replace n with k's. Okay, k into k minus 1 flow division 2. And at the end, we will just simply return your answer. So this was the complete solution. Let's check out the test cases. Yeah, so the test case got clear. Let's submit for further evaluation. Okay. Yeah, awesome. So the solution got accepted, and I would say like we performed decent. We outperformed 46.62% of the submitted solutions. So yeah, thanks again guys for watching out the video and stay tuned for the upcoming ones. Don't forget to subscribe to the channel. Thank you.